All right, everyone. Hello, thank you for joining us today. Welcome to our Eco Talks. I have the privilege today of introducing the person that will be introducing our speakers. So Anders Kraft is a student in our environmental science master's program here at Georgetown University. And he was an intern and part-time employee with our speaker and is the reason our amazing speaker is here. So just want to give a shout out to Anders, say thank you to him, and let you introduce our speaker. So thanks, everyone.
All right. Good morning, everyone. I didn't have anything prepared today, but I do have the pleasure of introducing Sam Droege, who is I call him a native bee fanatic, one of the most interesting people I've ever met. I had the pleasure of working at his lab for probably about 5 years. I interned there in high school and then worked there throughout my undergrad career, doing all kinds of things like catching bees, pinning bees, taking pictures of bees. Maybe you'll see some in the slides today. But I know he has a ton to talk about, to teach you guys about native bees, which I think is a really understudied topic, and I'm sure you're going to learn a ton from him. So without further ado, I'll give him the floor.
Thank you, Andrew. Thank you, Rebecca. We don't have time for me to tell all the Andrew stories I have. Should I modify the mic setup? Okay. Right. So I want you to think today that each of the slides that I'm going to show is like a gigantic server farm. Below each of those slides is so many more details, so much more information, so many interesting things that we could talk about when we don't have time. So these are introductory slides to a large extent. And really what I want to speak to is, I want to speak to the relationship of the native bee communities throughout the region, a little bit historical, not too much, and the urban, suburban to some extent, but primarily urban. These are the severe environments, right? Urban areas and farming, row crops. And what's that interaction and how to think about that? And then there's some unresolved questions. So first thing, honeybees, not a good model. Anything you know about honeybees, you should just eliminate because the native species do very different things. And in a very broad way, about 4,000 species of native bees in North America, many undescribed still. West, we have 2,000 California, 1,000 in Texas. East of the Mississippi is much lower general species richness, only about 800 species, more or less documented. In Maryland, we have about 450. We're working that up. A lot of taxonomic issues to resolve. Our park, Prince George's County, where it happens I live and work, about 300 species within there. And then in comparison, the UK, only 250 species. So the deserts of the Southwest, huge amounts of biodiversity, but continental landmass of the United States also has a great deal of biodiversity, particularly if you compare also to continental Europe, it's far higher in general. In terms of non-native species, there are quite a number, maybe 40 around North America. Regionally, there's about 20. The red ones are ones that have shown up since like roughly 1980. So we're continuing to accumulate these non-native species into the region, another whole topic. For your general information and to think about as I'm talking, most of these native species are solitary and nest in the ground. Many exceptions, but just keep that in mind as we speak about what's going on. So here, just that comparison, PG County, 300, UK, 270, 260 number of species. Maryland is a tenth the size of the UK. PG County is one of 25 counties, 23 counties, 2 cities in the region. So you can do the math. We have a lot of biodiversity packed into a small area. On top of that, we have a lot of taxonomic issues and identification problems. Mostly bee work is microscope work. You can, with some experience, but you have to eliminate all the other species that look alike, do things with binoculars like the butterfly people do. It's possible, but it's largely a collect and kill and look under the microscope and database, and that's what we do. When we think about loss of biodiversity, in 2010 we did a paper looking for what species have been recorded or on the books. It doesn't necessarily mean that they're taxonomically correct and have not been seen in the last 20 years. And of that 800, only about 37 showed up. And if you look at the pattern is rare and extremely rare to begin with, very few records, and taxonomically problematic in some cases. Subsequent to that, about half of those have shown up, like someone saw them at some point now that more people are simply looking for them. So if you don't look and you don't look at the right place, you don't find a lot of these species that are uncommon or rare. It also points out that we're probably not in a endangerment situation to a large extent. These are small, mostly the average size is the grain of rice. It takes only a relatively small amount of habitat, as you'll see, to retain these species. So somewhere we still have probably the entire fauna with a couple bumblebees as exceptions that I don't have time to talk about. So if we look at also abundance, super back of the envelope, we estimate about 27,000 bees are produced per acre per year in Maryland. That's average. Okay, that's a lot. That's basically what, I don't know if those numbers, 211 billion or trillion. It's a lot. There's a lot of bees. So again, this capacity to fill, refill, disperse, and that, and then you realize one honeybee colony, if it's a healthy one, produces 200,000 bees in a year. That's the number, as you'll see, we collected in our past 20-some years of collecting bees. So we're only fractionally looking at a small sample, cross sample, really, of the species in the region. So when thinking about sampling, you basically have to think about, I need to get a lot of bees, okay? Or you're sampling, you have sampling problems. So another example, they're exothermic, they're small. It doesn't take much energy to produce a baby bee. So like one sunflower head basically has enough pollen, not that it's all being used, but enough pollen for hundreds of bees. And they use that often when they're doing colony raising kinds of things. It's accessible. The rest of the species, we usually talk about 5 flowers equals 1 baby bee in terms of amounts. Lots of shady details in there. Here's our sampling in the region. You can see the fuzzy outline of Maryland in there. We also spend a lot of time in West Virginia. So we have 8,400 separate collection events over the past 20-some years. Andrew was involved with some of those, and almost 200,000 bees, and 9,300 were in the DC area, and the rest in Maryland. So we focused in on the metropolitan area. Baltimore up here, we have a list, and this is all public domain. I'm glad to send you the entire database and breakdowns by county and city. So we have a list of about 127 species for Baltimore. We have for DC about 227, many legacy from the national collection. So there were active curators who went out on the trolley line and on the rail line and collected the region and have bees for DC, for which it is unlikely they're still there because there was farms back then, up on Colorama, for example. And then Patuxent, which is this green triangle in the middle, is the refuge where we work. And we have a list so far of 200 species. So that gives you a little bit of contrast. We still have, again, we're retaining most of the rare species. All 3 of those areas have very unusual, uncommon species in them. If you look at overall records, this is the sort of a classic. So this first column, the bottom are a number of individuals collected per species, and you can see that the frequency is that almost everything is collected in handfuls. So a basic bee, and look at the number of records that we just have one specimen. So if we have just one specimen, that means we have a lot of species that are 0, right? It's just a sampling problem. And if we do the little calculations, we come up with, there's probably another 80 species in the system that we have not documented that are likely there just based on the math of the number of records in there. So much to do, a lot of rarity, still retaining globally a lot of the species. Let's take a look at what the patterns are within those, within native bees as a whole. So when we think about native bees, when we think about it, we think about a few, not too many, a few habitat types as being important. And the habitat types here, sand, forest, scrub, open, wetland, I'll talk about a little bit more. But basically, what we're talking about, these are the species that if you remove the wetlands, those wetland species would disappear. If we remove the forest into scrub, and remember in the area, it's always a gradient. So there's always a disturbance cycle of some kind. We're dominating that now. But in the past, it was something else that's moving things between a scrub or partial scrub or open, and trees fall down or burn or whatever. And situations, so we lump those together. If we remove those, we remove 71 species that are really locked into that. We look at open areas, so these are fields, meadows, whatever you want to call it. It's a mixed thing, it leaks into the scrub a lot of times, of course, because of succession, which is an unusual habitat if you think about a natural system in the region. It's almost always a man-pushed in reality, because if all the people disappear, this would go back to forest. Everything would be forest here except for Chain Ridge Flats, disturbance scour zone, barrier islands, edges of wetlands, edges of streams, those kinds of things. All the barrens, everything, like if you go up to Soldiers Delight, it's a really rough soil type. It's full of chrome and aluminum, very toxic, but it is succeeding back with pine, taking the front edge, and they have to push that back all the time. Indians, since about 20,000 years ago, it's documented, at the glacial maximum, that was their tool, fire. They burned the hell out of the whole area all the time. Spring burns, fall burns. You can look at the pine pollen, little scales or graphs, and you see that there was constantly pine. Pine has to come in on bare soil. It meant that even if you don't have the burns, which a lot of times we do, we know that that environment was burning all the time, but naturally lightning strikes occur almost entirely in the summer. It's such a wet environment that essentially natural strikes, which they do keep track of, almost never result in any kind of significant acreage burned in the state. It's all still human-dominated burning systems. So this these open communities of bees, which you can see by just the number, 257, would have been greatly restricted if it weren't for human intervention, let's call it, and largely has, as you'll see, a prairie element, like things come in from the prairie, things come in from the south on those kinds of things. And then the other two categories, which are not really habitats that have species groups that are retained there, are urban tolerant species. So there's a few that really do well just in any kind of environment, in any kind of urban environment. And just, there's a bunch of rare stuff, so let's call it. And so we have lists of those too. So if we look at rarity and we say, okay, well, what hasn't been seen in 100 years? We have the national collection here. There were curators that were really focused on bees 100 years ago, and those people collected a lot, and we have their specimens. We still haven't done, this is something to note on a good project, we still haven't gone through the collection and database the regional bees. We have a good idea of that, but not complete. But when we look at, well, what we have picked up in our, I didn't know we had that species in the area, I'm writing it down. When we look through that list, we have a group that has not been re-seen. And if we look at this again, like those missing species globally that we're never seeing, these species haven't been seen in 100 years. I realize I'm pointing at my screen, but you should be looking that it's up there. And so in the green, what you're seeing are specialists on plants. I'll talk about that in a little bit. So these are really only locked into a couple plant groups. Those plant groups disappear, they disappear. You don't look at those plant groups, you don't find them. And then we have some generalists that have their own story, which we don't have time for, and a whole series of nest parasites that are rare because they're parasites and maybe are on relatively rare species. So we have low numbers, a few of which have not been seen. But in comparison, this is a small list compared to the ones that we have recited. We've recited, therefore, almost everything, and we've added many more species to that original Smithsonian list. So if we think, insect apocalypse, bee decline, if we look at a landscape level, we really don't have a problem that we would document by doing this, we had to do some fun mathematical things on it to look at species, species curves, detection curves and things. But the basic story is we have found many more species in the area than the hunters of bees did in the old days. So that was their goal, find rare stuff, really, if you want to summarize the old collectors. Interesting side project. Western extent of distribution. So what we looked at is like, okay, here's a list of species. How far west do those species, their ranges extend? And we can see in red are things of significance. So the sand-using species, are ones that require sand. Sometimes open sand, usually, but a lot of times there definitely has to be a large proportion of sand in the soil type for them to occur in there. It's not super many, but one of the interesting things is that, and you'll see this later, most of those are southern species that have moved north. And so when we look at their extent, a lot of them are eastern, same with forest, even more so. Also, look at forests are eastern. And the deciduous forests that have many of the plants that they specialize on are only found in the east. And so that's where most of the bees are. Mostly trees are not things that bees specialize on. That's a generalist system. Wetlands, and then we look at open, their ranges extend well to the west. So we have prairie, we have western species in there. So again, sort of showing that our open species are species that probably were, moved in post-glacial maximum. This place was taiga and tundra. And you only have to go up into southern Pennsylvania to find glacial edge going on at the maximum. Very different environment, not that long ago geologically. And the Indians were there right at 20,000 years ago, altering the environment as we go along. And so when we go further down, wetlands, small group of species, willow, pontidaria specialists are driving a lot of this system in there. And we look at urban areas. Again, urban areas, it's sort of a ubiquitous. One urban area is really comparable to many other urban areas, and species are inhabiting a lot of those. High proportion of non-natives. A lot of that is moving from these species groups that have just moved into the area and are repopulating all these urban sites. So we expect to see even more of these things hit the West Coast that just haven't had the time. And rare species, most of the rare species are eastern. When we look at north-south distributions, we see that mostly the sand specialists are coming from the south. This would make sense if prior to the last glacial maximum, there was largely closed forests and also was cold. Right? And so really these sand specialists don't like the cold. So you don't see them moving further to the north. There's very little action, even though there's a lot of sand up there further to the north. And you have many, many sand specialists to the south. And one of the reasons is it's a burn system. Those areas like the central Lake Wales Ridge and north into Georgia and a lot of the southern areas, that's lightning strikes in the summer. It causes those areas to burn. There's enough fuel, there's enough weather, there's enough lightning throughout a whole much more extended time period that those areas are traditionally burned and should be thought of as having prairie elements and a lot of rare endemic species from that area. And I believe that most of they just took advantage of the fact that those openings extended north as the indigenous groups and also as the colonists always maintained them until recently, where we have a closing in of a lot of these forests. Another interesting topic. And then you can see that a lot of the rarity is basically to the north, possibly because the rare northern species that were here in glacial maximum have had to shift north, and these may be residual ones. Just, storytelling there. So specialists are bees that use a set of plants. This is our definition. You can find it in many ways. There's no set that are using plants at the plant family level and below. Often it's one-to-one. Pontidaria is a good example. And a lot of times it's at the genus. Salix, willow has 8 species, only go to willow. Remove willow, those species are gone. there's a management action for a lot of these, which is you have to bring in your specialist plants to have the specialists to have this broad component instead of your crow and sparrow bees, which are good with a broad range of different species of plants for their pollen and nectar issues. So if you look at this, we see that sand specialists, sand bees, sand using bees have lots of specialists. Wetland species, willow and Contidaria have lots of specialist species, and the others have moderate amounts. Urban areas, probably no surprise, no specialists are located within urban areas because the urban area food pollen resource in general is not is weeds and generalist plants rather than some very highly evolved plant bee relationship kinds of things. They are there, and as we'll talk about if we have time, is if you plant it, they will come, but nobody plants them, so they don't come. Bee City potential. We have lists of all the specialist bees. If you're interested in them, I can email a million links to things. If you, my email will be at the end. If we look at seasonal patterns, so in the sand group, that's a composite open area system. You don't have woodland sand bees, but you basically have to have these big open areas. Most of them are summer species, which is the low ebb for bee populations in general, by the way. And then we look at forest and scrub, we see almost all of that is in the spring. A few leak in the summer. Most of those are scrub things, sumac and blackberry and a couple other things are blooming in the successional stages into the summer. All the trees, subcanopy, the herbaceous understory are blooming in the spring. And then in that middle of that forest, by June, it's done. There are no bees in there because there's no bloom. And wetlands, we have a little more towards the spring again. Urban areas right there in the middle. Again, open country stuff. And the same with open country and rare for whatever reason. Okay, dispersal. So one of the issues in terms of a conservation point of view of bees is, well, if I plant these things, is any bee going to show up? Like, what's the nearest one? First of all, guess what? We don't know where the plants are. We don't know where the bees are to a large extent. We have an information poor system that we're dealing with. So what do we see when we see things? So one is Poplar Island, which is this right here. It's that's Talbot County on the eastern shore. It was an area that they created to dump dredge spoil from Baltimore Harbor. There were islands there, but you can barely see here. They maybe formed an acre or two of very limited marshy tumps, a very limited number of species, therefore very limited number of bees, even though we don't know what the bees are. But when we went in there and it just did a year trapping survey, so no netting or anything else, that often brings in some of the specialists and whatnot, 100 species of bees in that first year. Okay, they had to be, that's 2 kilometers from the nearest landfall, new habitat. They all had to cross that habitat at some point and then nest and begin a population large enough so that we could catch them. And their numbers out there are probably huge. Maybe there's commuting back and forth. Well, certainly there is some, right? So, anyway, it points out that if we look at Washington, D.C. and Baltimore and look at distances, as we'll just touch on, that's every part of Washington, D.C. is available for colonization. So we have not urbanized things to an extent that we cannot recover these systems. So, and then there are species that were found on Poplar Island that were new for the state and globally rare. So it's not like, well, yes, there's 100 species, but they're all the dirtball species that, everybody gets. No, there's a lot of rarity, and I don't have even time, but we do have a paper on it to talk about that. Another fun was Redskin Stadium. We set up a grid of traps in the middle. This is what students are for, right? And we sat there and the students just walked up and down the traps. The idea, the thought was how far into the, half mile by, quarter mile solid parking lot. You can see a couple trees in there now along these roads. Those were not there when we did this study. It was not a crack with a weed in it. It was like perfect. And so the notion was there's stuff along the edges because there always is in all these houses. How far are they going in and detecting the traps and investigating them and falling in? And the answer was no pattern. The ones in the bowls in the middle had just as much of a chance of finding or catching a bee as the ones on the edges. Again, all I want you to take home, bees disperse and travel large distances. Mostly they're probably dispersing from their natal site. Come out of the ground, there's no relationship with any other bees, there's no app for them, where is the good plant that I love? And if they don't find it in the immediate area, which is usually what they do, right? Because that's they have a nest there for a reason, they start flying and they either find it or they're dead. Not super smart, flying over the water. Maybe just Washington, D.C. is not a place they should be flying over in general, but they do. And so again, don't limit your thinking when you're doing plantings that you don't make any difference. And remember, they're small, so backyards are a huge, vast container for many, many species. Bees are one of the best because of their dispersal ability. Another just example, Mount Cuba, northern Delaware, formerly just, I don't know what to call it, but they planted the heck out of it. It's definitely worth a visit. It's a public garden now. And many, many native plants of many, many different species, mostly vernal because it's wooded. And they got a whole long list of new state records. This is just the new state records. And many, many very rare species, or what we think are rare. Because Matt Sarver, who did the project, had our list of specialist bees and said, okay, I'm going to spend a lot of time looking at Jacob's ladder. And he found Andrena pulmonii, which wasn't known for Delaware, wasn't known for Maryland, and the nearest record was the border of Ohio and West Virginia. So it didn't fly from there. For sure, we're just missing populations because this bee really is tiny. So, but who knows? I can't really say. But what I again want to point out is this: you build it, they will come. Here is a bee that hasn't been seen in 100 years in Maryland, Andrena, Cleides estivalis, not Andrena, that's right. And it's a specialist on heuchera. Heuchera is widely planted, usually hybrids, probably inappropriate. Heuchera americana is its jam. And Wendy Brister, who's just across the border in York, had it in her yard. Nothing special yard. It wasn't like surrounded by woods or anything. And she planted a few plants. She said, what's this bee? You know, because she knows that I'm interested in Heuchera americana, and it was the specialist species. So again, we probably have it in the state. We just haven't visited. Here's another thing. We've discovered this one, daughter, which I never bothered, but Tim McMahon was bored in October. There was nothing else blooming. He noticed some daughter. He collected off it, Cleides ciliatus. And it turns out super rare bee, probably because no one collects off daughter. And when we started asking other people to collect on daughter and to look at other records, it turns out that there is a subgenus of bees in the same group. They probably are daughter specialists. So Dionomia nevadensis is a species, nearest record is North Carolina. This one was a couple miles from my house in an old, my favorite collecting spot, one of these old gravel sand operations. And we still have never found that again in the state, and no one in Virginia has found it. So I'm pointing out just this degree of rarity, scarcity, and lack of investigation all works together to create a sort of a mystery about what the status of bees are. And that's why people ask, like, well, how are bees doing? I go, like, I don't know. And we still can find most is basically all I can tell them, because we have this inability to really document well what's going on. But we can tell stories, as you can tell. And okay, so let's dive now into these harsh, super low diversity environments and talk about them. So agriculture, here's agriculture 100 years ago. Note, child labor. Is that gone? No, it's still there, actually, in farming. But look at the understory. Look at all that biodiversity down there. And look at the soils are probably alive, right? There's probably a whole spectrum of bacteria and fungal communities, and it's all working together, providing most of the fertilizer and then you send the children in to pick all the crops. Now, a lot of agriculture, not all, there's some changes in agriculture. Basically, a farmer's job is to kill everything. They spend all day killing things and finding things to kill. I got to herbicide that. I got to apply pesticides that the soil's dead. I apply chemicals, not biology, to recreate and provide the things that plant needs. Very sophisticated, very expensive, very different. There are no bees in tilled row crops. No bee, I should say, there are bees. No bee can sustain itself in a row crop system, okay? Which is different from the interactions, and I'll point that out. Okay, here, I just randomly chose a place on the eastern shore. There's this matrix. Look at this. Here's row crops, and here's a little, actually, there was an orchard there. There's not that many left. And here are these residual areas. These are your bank. Incredible amounts of biodiversity, equally as ancient and interconnected as anywhere else in the entire world. And we generally dismiss that, like we're going to go to the Amazon or going to some other, faraway place where it's untrammeled. This retains most of the species and the biodiversity from the soil to the top. Each plant is providing a whole microcosm. Is that the right thing? Microcosm of fungal and bacterial communities down there that are unique to that plant usually. And above ground, you have incredible amount of specialization on just the insect communities. Many of those communities we know very little about, like leaf miners. Who knows much about them? Many leaf miners, though, highly specialized. I only go to certain kinds of wild lettuce and so forth. Doug Ptolemy's work is an exception, and that's because moth and butterfly people really have their act together. And you can see from his work, which I think most of you know that message, which is you need to have native plants to support caterpillar communities, and there's outfall from that in terms of supporting the vertebrate communities that using those caterpillars. When you have a community that's primarily not native plants, you have basically a highly simplified system. Basically, it's like in the ocean having just a bunch of algae around instead of coral reefs. So let's go to the next page and we look at this. Here's an orchard here. Oops. There's an orchard. A lot of orchards, apples and cherries need pollinators. Where are they coming from? You can plug honeybees in there, but when you actually look at what's going on, a lot of native bees are working in a lot of these systems. They are not coming from this lava-like pine forest because there is no flowers at all in there. This is a 0 for pollinators, probably most everything else. Back here is a big wood line. That's one of those woodlots we saw. That's where they're coming from. Okay, so they move in for the short period of time that those rosaceous plants bloom. So rosaceous plants are party plants. They bloom for about a week and a half, and then after that, they're done. They can't support specialist bees because they bloom infrequently, but they provide tons of pollen and nectar, very little chemical, very few chemical products in there that repel bees or that kill bees, because that's what many of the specialist plants do. They load them with secondary compounds. Anyway, this is like everyone come here, so all the bees out in the woods look out, see, so to speak, a sea of bloom. They're moving in. So they move in, they leave, and you want more, you work that system. Instead of mowing everything here, they still need pollen and nectar. So there's many opportunities here to take this area, for example, this lawn, which is providing negligible pollen and nectar, but might provide some nesting opportunity to support the bees that are coming to an orchard and fill in the blank, any kind of agriculture. I'll point out that there might be nesting bees in there. Most of those are going to be small little lazy blossoms locally nesting. Most of the bees that are coming into orchards are probably nesting in open environments that are man-dominated, but they're going to be in the shady drip line of the forests that cause less of the area to be grassy, more bare open soils. And that can be a school. So many schools are like, can you come? There's all these bees on the playground or where like they have a little playground tucked in next to the woods, and I'm like, this is great. They are not going to sting you. You're doing a good job. Don't try and kill them, but of course they do. So here we look at now one of these woodlots. That area, ericaceous. There's a set of species of bees that are using those woods. Depending on the species groups and the trees will depend on which species are present and how they move into the environment. This is in a forest environment, relatively low use by bees in terms of total numbers and capacity because it's a very unfloral rich. You have ericaceous shrubs dominating, which have specialist bees, and then some of the tree species have bloom, but mostly oak hickory are not interacting with bee populations. You move to the bottomland, which can't be nearby there. Most of the, on the eastern shore, a forested area is too wet to plow. You get the sweet soil vernal plant species. Those are the ones that are moving in. You get a range of trees that are also supporting, often congeners, so prunus, cherry, malus, and apple, and we have native crabs that are doing that. And you move into further western Maryland, you have lots of sweet soils, and you have all that richness of bloom in the highest densities of bees in the region. So that's your thing of biodiversity for many, many, many things. And also we need to let people know that stewardship is to not just talk about like I have 5 more cover crops in my field, but that I'm maintaining this other area, which is not making me money per se, but it should be equal to that. Okay, this area, same thing, same area, 5 acres of lawn. Lawn supports a very few, very small number can pull off their life cycle in here, but they are the crows and sparrows of the bee world. They do not need our help. There's no conservation value here. That should be flipped to native, larger plants that can have conservation value. And we're supporting specialists, we're supporting a more generalized, biodiverse community. Don't kid yourself about no mow may. Let's be a pump about things. And so we look at this spot here. Okay, farm field, row crops, nothing in the row crop. You plant soybeans though, bees move in. Soy are bean plants, they have flowers. Farmer knows they are self-pollinated. Yield increases when bees visit that plant, visit cotton, visit peach, these other things that are known to be self-pollinated systems. And so the way to talk about this in the soy world is that's free money. You have maximized your nitrogen and all these other factors and your other kinds of things you apply directly, or you have things, but you can get more yield, i.e. you get more money in the bank, if you will, by just having a bee-friendly environment, but not a forested one, because those bloom in the summer. The bees that use that area don't live in a forest. They live in an area like, can you see that? Yeah. Like here, which is too wet to plow, right? So this area, the ditch line, those could be spots. They're not because you mowed it. Anytime you mow in the summer, you're mowing your potential floral resource bank for the bees that might be providing you money if you're a farmer, and if you're a conservationist too, and that's a negative. So mowing in the winter is the way to go, early fall, so you can get your equipment. Here's another example, roadside, you can barely make out, why am I pointing at this? Oops. Messed it up. Now I've expanded it somehow. Wow. What if I hit escape? There we go. If we go here, what we're seeing is a power line. Power lines often follow roads because it's easy. And they're not big. It's not a transmission line, which also often are really good for bees. But you can't let the trees grow up too tall in there. Here's a natural opportunity. Oh, we're getting in Baltimore. Right, here is a natural opportunity to lights coming in. You have an open understory. A lot of people on the shore and elsewhere have their highway departments mow that area so it looks good. This looks junky to most people. I get their point, but it's actually hugely biodiverse and much more biodiverse than that first one that we saw, just because it has some open area and has light coming in. Okay, I could talk forever about. You can just give me a picture and I'll tell you why you're doing a bad job. So here we have the Baltimore, there's Patuxent again, and DC axis. So when we look at this, there's another environment highly modified. Here is Baltimore Harbor. We have a paper, very simple. We went a day and a half into the harbor. We walked the railroad lines. We met all kinds of sketchy people, the old abandoned docks. Like, it was industrial out the wazoo. There are still plants there. We still found in those 2 days in this low environment 50 species of bees, but 11 of them were not native. But still, it's waiting to have a introduction of more native plants. It's another opportunity. We see that as just a waste. But any of these little lots that you pass when you're driving in and out of DC, all these areas, doesn't take much. And that can be a positive. DC, you have your highly urbanized area that's largely maintained as culturally appropriate, mowed grass, a few planted things. You move into your more diverse sector here where people like to plant other things. The edge of Georgetown that I came through off of M Street, beautiful. I'll just, an aside, but you can have that subsidized environment. It blooms all the time. But if you go in and then have the mosquito people spray it, then you have created a death trap. It hasn't been studied much, so I'm really talking through my hat on that one, but it just seems like this could be a really big problem if you're attracting them to in their lives. So, but Rock Creek Park, so we've got collections throughout these areas. Retains a lot of, pretty much all of the native plants that would be in that forested bottomland area. They control Ficaria, the lesser celandine, which basically destroys all along here, all the understory native vernal plants within the region. You have here Chainbridge Flats, which needs to be studied because right next door, open scour zone. You have the various islands in the river, the Anacostia complex, all dumps, but still lots of things that retain some elements of native habitats and open country stuff on the eastern side. On the western side, you have the National Arboretum. We've gone in there. All the forests are mature, original forests interspersed with weird exotic trees, lots of native bee biodiversity within there. And anyway, and then up here, Plummer's Island has been well studied, many species in there. And you have the Natural History Collection that has documented what used to be in the region. You even go to the National Mall, you look at the gardens at the Natural History Museum again, look at the Botanic Garden. Many of the plants some of the plants are native and have specialist bees, and the bees are there. So I'm pointing out those systems. But in some of these places, we did a woodland study. So we wanted to go into some of these really tiny places. This is in Northeast, I think. Just little woodlots. That's basically a block of woods. This is, I think, the Franciscan monastery system. They have woods. We didn't ask to go in there. Anyway, it turns out those forests largely have what you would expect outside of a city environment, which is high biodiversity. Forest specialist species still persist within there, and they are communicating now with the surrounding area. So this is one of the areas that's interesting. So it's not like, okay, well, we're going to preserve that. Everything else is waste. If you think about what people plant, they plant woody ornamentals, right? And shrubs and all kinds of things, some of which are just weirdly over-cultivated. But many are native or close to. Remember, those are party plants, mostly rosaceous kinds of things. So some of the flowering cherries, some of the flowering plums, and I want to plant an apple tree in my backyard. The bees see no difference. So there is some interaction that needs a lot of study between the area that is always going to retain those bees and these weird environments. You know, can that whole collection of ornamentals support bee populations outside of some area that is not a natural area? I think the answer is probably yes, but what those details are, what is even the species, the absolute species list of those ornamental systems, is really only like, we'll collect off them every once in a while by happenstance. We see large species lists in these areas, but the question is now, are they nesting throughout the local area? What about that gradient from highly developed, think of Capitol Hill, but still people like to plant their little plots, to lower income areas where basically it's tree poor and people don't have the time and abilities to plant those with species rich things, to the northwest, which is big trees, all kinds of cool plants. And then you have these different systems that have natural areas. An example, Sidwell Friends School, not far from here, basically completely surrounded by urban areas of the more upper class, therefore more plant biodiversity being planted in there. And I just worked with the kids on a couple classes. I knew the teachers, and very casually we've documented nearly 90 species of bees in that campus. That campus is super used, like it's all playing fields with parking lots under them. And this area over here has some interesting bees, but this is an old concrete dump. There's huge slabs of concrete. It's just not designed. No one would go in there and be like, oh my God, what a great place. But it still has lots of biodiversity in there. Again, indicating that there's more going on than we know. It's more than those bees that I can find in people's lawns. So this list is probably larger. What's going on in an urban system is probably more complex, has more opportunities, but it's really not been documented. So what do we suggest to people in terms of how things get planted and used? What is going on? What species will move in? What species will not move in? So anyway, saving bees is basically about saving biodiversity of plants because of all the specialization. Each bee has a very small Rolodex of the plants it's willing to visit. So you can't clover your way out of the bee system. Mowing is basically something to look at very closely. In the facilities world, a lot of times you're mowing that playing field right up to the woods edge. Nobody plays at that woods edge. What if you left a mower deck unmowed throughout the year? What about some of these woodlots on campus or elsewhere or unused spaces? Why not just not mow them in a year? Why not flip them into environments that are filled more with perennials versus just grass? So here's an example of how we approach that. That can be done at the scale of anyone's backyard. And we're doing it at very large scale for our research gardens. I haven't really mentioned. People are welcome to come visit me, work with me. And Anders can tell you all kinds of stories about being out there. We have hoop houses. We have research plots that we're growing different native plants to look at bee-plant interactions. We have a huge collection and a new building coming in. Space for researchers, free Wi-Fi. Actually, we do have coffee. What am I saying? So here, for example, this was at my yard. I wanted to flip this. I just buried it in. This is the approach we use. Just buried the whole thing. You don't have to mow it. You don't have to turn the soil. Don't put down cardboard. Don't put down newspaper. You bury it in wood chips that the region's tree companies have a hard time getting rid of. They give you for free by the whole truckload. 12 inches, 8 to 12 inches. You can have the woods chipped that day, delivered that day. You can bury the area. You can move a little crater and plant that day in that soil. And you'll be fine. There's no we're removing the nitrogen, all this kind of stuff, which is basically just hearsay. And mostly about sawdust, not these chips. It smothers, it provides moisture. The invertebrates are like, oh, look, carbon. And they start rototilling the soil for you underneath. You create fungal networks instantly, and you have the bacteria that also add in there. The plants love it. We have environments. So that's the next year. And here is a gravel parking lot on our entrance. See right here, this is gravel. And it was designed just to hold a bunch of cars. We just rototilled it very quickly to knock back the crabgrass, buried it, planted it, no watering, walked away, and it's self-maintained with just a little bit of fooling around just to make it look better. And then now it's a source of plants for other people who want big, thuggy native plants that'll take over their garden. And so here's the bee lab. So same thing. This was all just chip. It was on top of the septic field. They did nothing there because it was all about raising endangered cranes in the past. My house. So the idea is within an environment in which you want to introduce complexity, most of the neighbors don't like that, right? It looks wild. It looks too negative space. So what you do is you string trim very precisely any human used space in there, the fence line, the sidewalks, the front, and then everything you do behind it, they don't really care. So there actually was a study somewhere that looked at that, and it turns out they don't necessarily know what you're doing there, but you're keeping up the handshake of the environment, which is presenting well. You did this on purpose. We don't know what you did in there, but it doesn't look like it's an abandoned lot. And so just a couple shots of my yard. I like to keep it extremely, so this is not for everybody, extremely wild, and I just use a weed whip in my acre to weed whip lines throughout that area for paths, and I'm constantly redoing these. So I'm using this for research too, and like a lot of the plants you see, this is a fairly old shot, have been replaced with something else. But again, it's just I dump chips on it, I chop things out that come up that I don't want, and we're good. Okay, last slide. So here's some things to think about that I think would need more research and could add a lot of information. You guys are in an urban environment, so something to consider. Ficaria, so that's just the invasive lesser celandine. It takes over the area. We did a very small study. We saw that the native bee populations in Ficaria area, which blooms, beautiful yellow flower, is 1/10 the number numerically than the areas in the same spot that for whatever reason still retain their native plants. Nesting locations. Where are things nesting in these urban, suburban environments? We come across the nest periodically. Come talk to me about finding nests, and which is a problem in itself. But that's something that really isn't considered. You talk about plants, we don't talk about nesting areas and creating that and fostering that kind of thing. Ornamental rosaceous plants, we spoke about this, potentially a lovely thing. But you double any kind of flower, that's the end. There's no pollen and nectar because you've taken the sexual organs and created a plant that no longer provides pollen and nectar. Same thing with any cultivar. Ultimately, you give the plant breeder a plant and they eventually use up all the pollen and nectar because they don't say, I want a plant with more pollen and nectar. Unless it's a crop plant, they want a plant that has bigger bloom, longer lives, shorter stature, robust, more disease resistant. And the plant eventually just harvests all the pollen and nectar energy, which is huge, and puts it into these other things. So straight natives usually is the way to go. But, there's interesting things to look at there. Gardens that people have, so people plant these native plant gardens, right? What's going on in there? Are they reservoirs? Are things going on? Oops, sorry. And when you're planting all these native plants back into this environment, what's the interaction between those native plant communities? You potentially have bees that are moving pollen and nectar around. There's residual areas with the same species. What is that, positive or negative? Are we helping climate change adaptivity by introducing molecular material into that, or is it just messing up all the native areas to begin with? Just a distribution of bees within a heavily urban area. Nice grid system, by the way. You can really plot those out in your GIS system. Chain bridge flats, we talked about. Almost no one has done any investigations of that area. It basically is a weird prairie that is completely native, completely run, not by burning, but by scouring. Plummer's Island, revisiting that, looking at that. John Will has done some work on that in the past, but needs to be done more. We have look at comparison of the information from DC, from the natural history collection to modern collections, look at what has changed. Can we find these species? Is there relative abundance difference? And then the mosquito control impacts to everything really is just not looked at. Cursor. Okay, I'm done. There's we have a lot of social media. All of our pictures are public domain. We have a catalog of 5,000. don't ask us to use them because we're going to say yes. And we have lots and lots of links. We do identification guides. We'll help you with identifying your bees because if you're a grad student, you can't do that and graduate at the same time. So we'll have more because of our new facility. We're going to have weekly training sessions. You can email me to get on that list. We're not quite ready yet, but that'll be something that it could be a resource here. I'm sure I've gone over my time, Rebecca.
You good? You got 3 more minutes.
3 minutes, amazing. I really have to talk fast and not use a lot of adverbs, adjectives. Okay.
Great. Thank you so much. So
we have a couple minutes for questions.
One more question. So first, thank you for the great talk. It's good to know that there is non-apocalyptic of this. So I have a question like a lot of insects like mosquitoes, aphids, psyllids, they are developing pesticide resistance. They are adapting, evolving to climate change. I am curious about what's going on with bees. Are they developing some kind of this resistance or adapting, evolving to climate change, global warming?
That is a good question. I don't think so. So in the past, because of honeybees and the interactions between honeybees and commodities, right? Honey, there has been a bunch of work on there, and there actually is, as part of the pesticide registration, work that looks at toxicity to hummingbirds, to honeybees, but they do it like an LD50, like okay. We have a very artificial system. We provide pesticides at different concentrations. How long does it take for half of them to die? And then we make our recommendations. But it turns out that when people start looking at pesticide interactions with bees, particularly native species, so honeybees, very weird, way out in one arm of the bee world system. So our native bee species are probably reacting very differently. When people have looked at that a little bit, they see lots of indirect impacts and non-lethal impacts. So mortality can go up, but it's not like an outright kill. They'll be like, oh, we can't find our way back to the nest. We provision poorly. So we look at the impacts on survivorship and fecundity, and it drops. But you wouldn't pick that up because you're not looking at them, first of all, and you're also not looking at them from a straight and a very kind of artificial LD50 thing. So that's about all we know right now is that there are probably many more kinds of impacts to pesticide applications than we have quantified. And so in a system like with aphids and psyllids, well, there are many aphids and psyllids. They have a very high reproductive rate, and they are in an environment where they're constantly being over and over again having pesticides applied to them. So the gradient, I don't know what, I'm not getting the right word, but that's the place that you would develop resistance. So bees are intersecting periodically, but probably at a rate that is difficult for them to develop a resistance aspect that, unlike the pest species. Does that make sense?
Thank you.
Okay, my question, thank you for talking to us today. Really appreciate it. My question is about trying to convert like grass lawns or grass areas. A lot of people, we assume like when we do green spaces, it's just like a plot almost of grass in the middle of like a city. How can we get, because I know this is happening in the West because of like water scarcity, the switch from like grass, like maybe imported from the East Coast to a more native habitats in the front and backyard. How can we get that to happen on this side of the country where there's more water security? And also, how can we, forget the rest of my question. Yeah, how can we do that?
Yeah, so it's really a cultural solution. We know how to do things biologically, but culturally, it's always acceptable to have nothing but lawn on your property. So that's the bottom line. It's easy. you get downgraded by your peers, by your neighbors, by the community, the HOA, anyone to having something other than that, other than maybe 5 evergreens at the corners of your house. So culturally, there has to be a shift. So I think work needs to be done on how to introduce people to planting more easier planting techniques, taking care of plants without them having to do a lot of time, looking at like, hey, you don't have to spend so much time on your riding lawnmower, you're saving gas, you're increasing carbon stores, you're not polluting as much. It's beautiful. Here's how to make it beautiful without having your neighbors, mow your grass while you're on vacation because they thought you maybe had died, that kind of thing. So I think doing some examples, and so something like on campus would be an interesting place to do experiments. There's probably some spots that you could try to do different kinds of examples. And you could then trial people, like, oh, look, you have all these populations out here. You could say, here's 3 things. Tell us which one you like the best and why you like it or why you don't like it. And then use that to inform, future things. So you look at it experimentally and as projects, but it's going to be a cultural solution because it is a wasteland. There is nothing valuable there. And you're dumping chemicals on there to keep everything but that one species of non-native grass alive and mowing it. A lot of that's shedding off. It might be better to have concrete on there, frankly, than an actual lawn. That's one other thing. So we know about forest bathing, really good thing. So why is it that when we build a house, we get rid of all the forest, absolutely everything, replace it with concrete, a grass, one species that's very difficult to maintain, and then dump a bunch of chemicals, and then when we go into that house, it's plastic, vinyl on the outside, and inside that is all acrylic and man-made environments. And we go out and do our forest bathing, and we come back and reverse it all, right? So I think another whole, from my point of view, another whole thing is, gosh, let's look at this from a human health point of view, that is your yard supporting your health? Why would you have to leave, right? If you had a beautiful yard, your forest bathing is called going outside to the patio. For most people, it's the opposite. I don't think that people are even aware of the soul-sucking nature of most of the environment that they live in all the time. They have become, all right, I'm really preaching now, like human zombies that are kept down by the man. Or something. Right? So I think, again, we have a lot of cultural investigations to think about here in terms of, like, you can't just plant and say, oh, I'm a scientist, like, you should do this. No, it has to be like Bob the neighbor is doing it. Oh, I want to do that. That's how the mosquito stuff is going. When you get that knock on the door, you don't see this as often, but that's how they work. You go into suburban neighborhoods, they say, well, Frank down the road is spraying for mosquitoes because we have problems. And you know what? The things that we spray, they don't impact pollinators. So they'll bullshit their way through a lot of information, and people are like, yeah. And then you're paying for that cost from now to infinity because you have a contract with them. Anyway, I have strong opinions.
Okay. That's our time. Thank you so much again to our speakers. I'm sure there are more questions, so we do have a schedule if you would like to talk to Priscilla about it this afternoon. I also want to let everyone know that next Friday, the 19th, we've got our Eco Spring Festival that's happening from 4 to 6, so please join us for that. And our talk next week is on eroding sovereignty and ecological realism, how climate change is making fools of the realists. So please